Hello coders. So today we are going to solve this problem which uses dynamic programming. Okay, so this problem says given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. Okay, so we have to calculate these blue part, I guess, and these black ones are the walls. Okay, upon going through the examples, we see that it's pretty easy to visualize what they actually want from us. It is just the volume of the water in these pits between the towers, and to achieve that, we can iteratively go to each element and find the amount of water storable in the particular pit itself, where pit is formed only if the height of the towers on that position is less than the minimum height of the two highest towers, which are maximum one to the left and one to the right. You must have figured out a brute force way to solve this problem. Let's see how are we going to achieve this solution by optimizing it. We need to pre-process this list in such a way that for every position, if we look up to the left, it gives the maximum height of all the towers to the left, and if you look up to the right, it gives the same for all the towers on the right. By doing so, we don't need to iterate the whole list every time. Now let's see how we are going to make this left greatest array. For that, we move from position 1 till the end of the array if for the current position the element is smaller than the previous element. Then we replace that element with the previous element. If not, then we keep it as it is, right? So let's iterate and form our left highest element. So 0 is copied as it is. Then we compare 1 and 0. So which is greater? 1. So 1 as it is. Now 0 and 1, 1 as it is, 1 and 2. So here we replace our new element which we are going to add with 2. So now 2 and 1, it's again 2, 2 and 0, it's again 2, 2 and 1, again 2. Now here it's again 3. So this new element will be 3. So on and so forth. We can see none of the element is greater than 3. So it goes 3, 3, 3, and 3. Okay, now we make the right greatest array. We leave last element as same in the array and move from right to left by checking if the current element is greater than the element before it. After we are done with the array, we iterate in our main array and perform the following operations. So last element is copied as it is, which is 1, and the second, which is 2 greater, it will be 2. So 1, 2, here, 2, here. See, 3 is greater than the previous one. So it will be 3. Here also, all the elements are smaller than 3. So at the end, the answer will be 3. So we will paste through this 3, 3, 3, 3, 3, 3, 3. Now we have our pre-processed two arrays, which we can use to find our solution. We will make a final result array, which we will compare these two elements, right? The minimum of these two minus the height of this, right? The position we are at. Here we have 1. So we need minimum height of these two to be at least greater than 1 to have water, right? But there's no such case, so the answer will be 0. Moving forward, we see here the height is 0 and the minimum of these two will give us 1. So 1 minus 0 gives us 1. That's the water in it. And going ahead, we see its minimum of these two is 1, which is smaller than 2. So no water can store here. So it's 0. Again here, we can store some water in it because minimum is 2 and the height on itself is 1. So it's 1. Here again, same. 2 is the height. Here, 1. And going ahead, we get the gist of it, like what's going on, and we get the total amount of water in it. And hence, this is the answer which we were looking for. Now let's code what we have learned so far. Okay, so first we will take care of the corner cases. And now we'll make our left highest array, which will be simply now we will make our result array.